Hello. We are now entering the topic on integration, which is the inverse of differentiation. So, continuing with our solutions on integration, uh, we would like to give you some of the, all the problems that have been given. We need to give you the solutions. As told, integration is the inverse of differentiation. Going to the first problem, it says we need to find integral of e power log x plus x squared dx. Going to our work area, e power log x plus x squared dx, e power log x is given as x, so x plus x squared dx integral would be x squared plus x squared by 2 plus x cubed by 3 plus a constant c. So the answer is option B. Going back to our PowerPoint projection, uh, it is B, which says it is x squared by 2 plus x cubed by 3 plus constant c or k. Second question, integral of 1 by x into x plus 1 dx. Going back to our work area, now 1 by x into x plus 1 dx can be put into partial fractions as integral of 1 by x minus 1 by x plus 1 dx. Now 1 by x, integral of 1 by x is log x, and the integral of 1 by x plus 1 is log of 1 x plus 1. So it is log x minus log of x plus 1 plus k. So the answer is option B. Going back to our PowerPoint projection, it is option B, which says log x minus log of 1 plus x plus k. Question 3, integral of dx by 2x plus 1 into 2x plus 3. Going back to our work area, now this 1 by 2x plus 1 into 2x plus 3 can be put it into partial fractions as half of integral 1 by 2x plus 1 minus 1 by 2x plus 3 dx. Now we know that if you have to integrate this, then we will get 1 by 2x plus 1 as half of log of 2x plus 1, and 1 by 2x plus 3 would be half of log 2x plus 3. So effectively it is 1 by 4 log of, actually absolute value of 2x plus 1 by 2x plus 3 plus k is a normal thing, because we don't take the log of a negative number which gets into the complex plane, and answer is option B. Going to our PowerPoint projection, it is option B, which says 1 by 4 log of 2x plus 1 by 2x plus 3 plus c. Very good. Fourth problem, integral of x minus 1 by x plus 1 whole squared dx. Going to our work area, integral x minus 1 by x plus 1 whole squared dx can be written as integral of x plus 1 minus 2 divided by x plus 1 whole squared dx, which can be further split as integral 1 by x plus 1 minus 2 by x plus 1 whole squared dx, which on integrating 1 by x plus 1 will result in log of x plus 1, and 2 by x plus 1 whole squared is nothing but, on integration, leaves you minus 2 power x plus 1 minus 1 divided by minus 1. So the net answer is log of 1 plus x plus 2 by 1 plus x plus k. So the answer is option C. Going to our PowerPoint projection, it is option C, which says log of x plus 1 plus 2 by x plus 1 plus c. Fifth question, integral of root x minus 2 divided by root x dx. Going back to our PowerPoint, work area, integral of root x minus 2 by root x dx is equal to integral of 1 by root x dx, which is equal to x on integrating 1 is x, integral of minus 2 by root x will be minus 2 x power plus half by plus half plus k. So that will work out to x minus 4 root x plus k. So the answer is option A. Going to our PowerPoint slide, it is option A. It says x minus 4 root x plus k. Question 6. Integral of 1 by x into 1 plus log x dx. Going to our work area. We put 1 plus log x as t. That is putting t equal to 1 plus log x. What happens is, when we differentiate on either side, dt would be equal to dx by x. Then we substitute the same thing back. So replacing dx by x as dt and 1 plus log x will be t. We have, when we integrate that, we get log t plus k. Now t is 1 plus log x, so the thing is log of 1 plus log x plus k. Of course, it is log of mod of 1 plus log x, generally written as log of 1 plus log x plus k. So the answer is option A. Going back to our PowerPoint presentation, it is A option, which says log of 1 plus log x plus c or k, the constant. 7th problem, integral of x cube plus 2x plus 3 divided by x power 4 plus 4x squared plus 12x plus 5 dx. Getting back to our worksheet, the given integration is as follows. Now substituting for the denominator, that is x power 4 plus 4x squared plus 12x plus 5 equal to t, differentiating on either side, we get 4 times x cube plus 2x plus 3 dx will be equal to dt, or the numerator portion along with dx will result in dt by 4. Then the original integral, we get it as integral dt by 4t, which is 1 by 4 log t plus k, or 1 by 4 log of x power 4 plus 4x squared plus 12x plus 5 plus k. So the answer is option A. Going back to our PowerPoint projection, it is option A. That is 1 by 4 log of x power 4 plus 4x squared plus 12x plus 5 plus c. 8th question, integral of x squared minus 1 by x squared e power x plus 1 by x dx. Going to our worksheet, we putting t equal to x plus 1 by x, we have on differentiating, dt will be equal to 1 minus 1 by x squared dx, or dt will be equal to x squared minus 1 by x squared into dx. For the original integral will be equal to integral, substitute x plus 1 by x as t, so e power t, and the dx into x squared minus 1 by x squared as into dx as dt. So we get integral of e power t dt is e power t plus k, and substituting the original value for t as x plus 1 by x, we have e power x plus 1 by x plus k. So the answer is option B. Going back to our PowerPoint projection, it is option B. It says e power x plus 1 by x plus k. 9th question. Ninth question, integral of x squared e power x dx. Going back to our worksheet, now integral x squared into e power x dx, we take u as, this is actually integration by parts. If you see, integral u dv equal to uv minus integral v du. Try to work out on this basis. Now we take x squared as u and e power x dx as dv. Then when we take u equal to x squared, du equal to 2x dx, dv is equal to e power x dx. So integral dv would be integral of e power x dx. So v will be e power x. So found all these things. Now integral, we know that integral of u dv equal to uv minus integral v du by parts. This is the general formula. So therefore we have integral x squared e power x dx based on this selection, e power x into x squared minus integral e power x into 2x dx. Again we have to do by parts, where we choose x component as u and e power x dx as v. Thereby we get it as the entire thing as x squared e power x as the previous one. Now minus of that x integral of x e power x dx, which becomes minus 2 of x into e power x minus e power x plus k. The same thing what we did, and we get it as e power x into x squared minus 2x plus 2 plus k. Answer is option A. And back to the PowerPoint presentation, it is option A, that is e power x x squared minus 2x plus 2 plus c. 10th problem, integral of x power x into 1 plus log x dx. Back to our worksheet, integral x power x into 1 plus log x dx. Substituting x power x equal to t and taking log on both sides, we have x log x equal to log t. Then differentiating, we have x into 1 by x plus 1 into log x dx will be equal to dt. Now, therefore 1 plus log x of dx will be dt by t. So getting back to our original integral, in terms of t, it would be integral t into dt by t, which is nothing but dt, which is equal to dt plus k. Now t was substituted as x power x, so we have the solution as x power x plus k. So the option is C. Going back to our PowerPoint presentation, it is option C, which is x power x plus k. 11th question, integral x e power x by 1 plus x whole squared dx. I repeat, question 11, integral x e power x by 1 plus x whole squared dx. We go to our worksheet. We can rewrite this integral as integral e power x. X can be split as x plus 1 minus 1 whole divided by 1 plus x whole squared dx, which can further be written as integral e power x bracket 1 by 1 plus x minus 1 by 1 plus x whole squared dx. We know that integral of e power x of f of x plus f dash of x dx is e power x f of x plus k. So here we have f of x as 1 by 1 plus x, means f dash of x will be minus 1 by 1 plus x squared, which tallies with the given integral equation. Now, so integral of x e power x by 1 plus x whole squared dx boils down to e power x by 1 plus x, because we know that it is e power x f of x and we took f of x as 1 by 1 plus x. So the final answer is e power x by 1 plus x plus k. Answer is option B. Going to our PowerPoint presentation, it is B, which says e power x by 1 plus x plus k. 12th question, we need to find the integral of x plus 2 by root of x squared plus 4x dx. Back to our worksheet, it will be integral of x plus 2 divided by root of x squared plus 4x dx. Substitute x squared plus 4x equal to t, and simplifying, we get finally x plus 2 dx equal to dt by 2. Putting back all the relevant things, the original integral becomes integral of dt by 2 root t, which is equal to root t plus k. Reverting to the original value for t equal to x squared plus 4x, the answer is root of x squared plus 4x plus k. So the answer is option D. Going back to our PowerPoint presentation, it is D, which says root of x squared plus 4x plus under the root square root of x squared plus 4x, and outside you have plus k constant. 13th problem, integral of x plus 2 by x plus 1 dx from 0 to 1. It's a definite integral. Reverting to our work area, integral x plus 2 by x plus 1 dx is can be rewritten as x plus 1 minus 1 by x plus 1, and then we get 1 minus 1 by 1 plus x dx. After integrating, you get as x minus log of x plus 1, and being a definite integral from 0 to 1, it is written like this. Substitute the upper limit, value of x equal to 1 in that obtained expression, x plus log of x plus 1, that is 1 plus x equal to 1, and then that will be log of 1 plus 1, which is log of 2, minus 0 plus log 1, which is equal to 1 plus log 2. Okay, so the answer is option D. Going back to our PowerPoint presentation, it is option D. It says 1 plus log 2. Question 14. Integral 0 to 2 f of x dx minus integral 0 to 2 f of 2 minus x dx. Going to our worksheet, integral 0 to 2 f of x dx minus integral 0 to 2 f of 2 minus x dx. We using the property of definite integrals, which is integral 0 to a of f of x dx is equal to 0 to a integral f of a minus x dx. So we get integral 0 to 2 f of x dx minus integral 0 to 2 f of a minus x dx as equal to 0. So the answer is option A. So we go to that PowerPoint presentation which says option A equal to 0. Question 15. Integral of root x, it's a definite integral from 0 to 2 root x by root x plus root of 2 minus x dx. Going to our worksheet, now integral 0 to 2 root x by root x plus root of 2 minus x dx is equal to I. Now using the previous property, that is which was told as integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Now we have integral 0 to 2 root x by root x plus root of 2 minus x dx equal to integral 0 to 2 root of 2 minus x by 2 minus x plus root x dx. So both are I. Now if you call this as the first equation and the next one as the second equation, I add together the first one with the second one, which is both i's. I plus I is 2i. That will add up, and on simplification we get it as integral 0 to 2 root x plus root 2 minus x by root x plus root 2 minus x dx, which is equal to integral 0 to 2 dx, which is equal to 2, or I is equal to 1. So the answer is option C. Going back to PowerPoint presentation, it is option C, that is equal to 1. 16th question, integral of x power n log x dx. Now going to the worksheet, using the same integration by parts, integral u dv equal to uv minus integral v du. This formula we can associate take u to be equal to log x here and dv to be equal to x power n dx. Now integrating this x power n log x dx would be log x into x power n plus 1 by n plus 1 minus 1 by n plus 1 integral of 1 by x into x power n plus 1 dx, which is nothing but 1 by n plus 1 whole square power n plus 1. So the total answer would be x power n plus 1 by n plus 1 into log x minus x power n plus 1 by n plus 1 whole squared plus a. Option A. Going to our PowerPoint presentation, it is option A. It is x power n by n plus 1 log x minus x power n plus 1 by n plus 1 whole squared plus k. Eighteenth question. If the marginal revenue for x units is 15 minus 9x minus 3x squared, then the revenue function need to be calculated. Going back to our worksheet, marginal revenue is given as dr by dx, which is equal to 15 minus 9x minus 3x squared. So when we want to find the revenue r, on integrating we get the function as 15x minus 9x squared by 2 minus 3x cubed by 3 plus k. Now when x is equal to 0, where x is the quantity, our revenue r will become 0. That is, no quantity, no revenue. So substituting r equals 0 and x equals 0 in the equation for r, we get k as 0. So therefore the revenue function r is equal to 15x minus 9 by 2 x squared minus x cubed. Answer is option B. Going to our PowerPoint presentation, it is option B, 15x minus 9x squared by 2 minus x cube. 19th problem, integral 10 power x plus x dx. Going to worksheet, integral 10 power x plus x dx is nothing but 10 power x by log 10 to the base e plus x when integrated gives x squared by 2, and we add a constant c. So the answer is option B. Going to our PowerPoint presentation, it is option B, which is 10 power x by log 10 to the base e plus x squared by 2 plus c constant. 20th problem, integral of x root of x squared plus 4 dx. Going to our worksheet, integral x root of x squared plus 4 dx. You substitute x squared plus 4 equal to t squared, differentiating on both sides. 2x dx is equal to 2t dt. X dx is equal to t dt. So you have integral t into under the square root you substitute t squared or x squared plus 4. So you get t. So t effectively you will be integrating t squared d with respect to t. So which is t cubed by 3 plus c. So the answer is x squared plus 4 power 3 by 2 divided by 3 plus c. So the answer is option B, which is again 1/3 of x squared plus 4 power 3 by 2 plus c. 21st problem, integral dx by x plus 3 into x plus 4. Going to our worksheet, now integral d 1 by x plus 3 into x plus 4 dx. You can rewrite this as integral of x plus 4 minus x plus 3 divided by x plus 3 by x plus 4 dx, and then simplifying you get integral of 1 by x plus 3 minus 1 by x plus 4, which you get it as log x plus 3 minus log x plus 4 plus c, which is equal to log of x plus 3 by x plus 4 plus c. So answer is option B. Going back to our PowerPoint presentation, it is option B, which is log of x plus 3 by x plus 4 plus c. 22nd problem, integral dx by 3x plus 5 into 3x plus 8. Going to our worksheet, we can rewrite that integral as 1/3 of 3x plus 8 minus 3x plus 5 divided by 3x plus 5 into 3x plus 8 dx. The same function. Now that is written as again into partial fraction, that will be 1 by 3 into 1 integral of 1 by 3x plus 5 minus 1 by 3x plus 8 of dx. On integrating we get it is equal to 1 by 3 of within brackets 1 by 3 of log x, log of 3x plus 5 is 1 by 3 of log 3x plus 8. So we get it equal to 1 by 9 of log of 3x plus 5 by 3x plus 8 plus c. Answer is option A. Going to our PowerPoint presentation, it is option A. It says 1 by 9 of log of 3x plus 8 by 3x plus 5 modulus, because log of a positive number is only generally considered, and that plus a constant c. 23rd problem, integral log of log x by x dx. Going to our worksheet, substituting log x equal to t, on differentiating on either side we get 1 by x dx equal to dt. Therefore the original integral becomes integral log t dt. We can take now log t to be equal to function u and dt to be equal to dv. We know that integral u dv equal to uv minus integral v du. We get log t dt will be equal to log t to t minus integral of t into 1 by t dt plus k. So that is equal to t log t minus t plus k. Replacing t with equal to log x, we get as log x into log of log x minus 1. So the answer is option D. Going to our PowerPoint presentation, option D, which says log x whole multiplied by log of log x minus 1 plus a constant c. 24th problem, integral of 1 by x log of log x into log x dx. Going to our PowerPoint presentation, work area, integral 1 by x log of log x into log x dx. We substitute log of log x equal to t. Differentiating on either side, we have 1 by log x into 1 by x dx will be equal to dt. Therefore the original integral becomes integral of dt, that is 1 by x log x dx replaced by dt, and log of log x, you have it as t, so dt by t. So we get equal to log t plus c, which is substituting back to the original expression, we get log of log x plus c. So the answer is option B. As shown, it is B, log of log x plus c. 25th problem, integral x squared plus 1 by x squared e power x power minus 1 by x dx. Going to a worksheet, we substitute x minus 1 by x equal to t. Then differentiating on either side, we get 1 plus 1 by x squared dx is equal to dt. On simplifying, you get x squared plus 1 by x squared dx equal to dt. Original integral is equal to integral e power t dt. That is, we replace x squared plus 1 by x squared dx by dt, and e power x minus 1 by x as e power t. So you get e power t plus c. Now reverting back to its original expression, that is, replace t by x minus 1 by x, get e power x minus 1 by x plus c. So the answer is option A. Going to our PowerPoint presentation, it is option A, which is e power x minus 1 by x plus c. 26th problem, integral e power x by e power x plus 3 dx. Going to our worksheet, we substitute e power x plus 3 equal to t. So differentiating on both sides, e power x dx equal to dt. So integral, it becomes integral dt by t equal to log t. We also write it as log of mod t, because there is only, we take the positive value inside a logarithmic function. So it is log mod of t plus c, or log of mod e power x plus 3 plus c, or option C. Going to our PowerPoint presentation, it is C option, which says log of e power x plus 3 plus c, under the consideration that e power x plus 3 is not negative. 27th problem, integral e power x within brackets log of x cube plus 2 plus 3x squared by x cube plus 2 dx. I go to the worksheet. Now if we take f of x equal to log of x cube plus 2, then f dash of x would be 3x squared by x cube plus 2. Using the property integral e power x of f of x plus f dash of x dx is equal to e power x f of x plus c, we get the integral to be equal to e power x into log of x cube plus 2 plus c. So the answer is option B. Going to our PowerPoint presentation, it is option B, which says e power x log x cube plus 2 plus c. 28th problem, integral e power x into x squared log x plus x divided by x squared dx. Going back to our worksheet, this can be further simplified as integral e power x, you divide x squared throughout, so you'll have e power x into log x plus 1 by x dx. Now we know that property that integral e power x f of x plus f dash of x whole dx would be equal to e power x f of x plus c. Here our f of x is log x, f dash x would be equal to 1 by x. So the integral value would be equal to e power x log x plus c. So the answer is option C. That is C as shown in PowerPoint presentation. So it is e power x log x plus c. 29th problem, integral 2x plus 2 root of x squared plus 2x plus 5 dx. Going back to our worksheet, substituting x squared plus 2x plus 5 equal to t, we have differentiating on both sides. It is 2x plus 2 dx will be equal to dt. So the original integral will become root t dt, which is equal to t power 3 by 2 by 3 by 2 plus k. That is 2 by 3 of x squared plus 2x plus 5 power 3 by 2 plus k. So the answer is option B. Going back to our PowerPoint, it is option B. 30th question, integral of 1 by root of x plus 1 minus root of x minus 1 dx. Going back to our work area, when we try to rationalize, that is multiply numerator and denominator by root of x plus 1 plus root of x minus 1, in that equation we get as root of x plus 1 plus root of x minus 1 divided by root of x plus 1 minus root of x minus 1 into root of x plus 1 plus root of x minus 1. The denominator would become x plus 1 minus x minus 1, and the numerator would be root of x plus 1 plus root of x minus 1 dx. And the denominator will become x plus 1 minus x minus 1 would be 2, which we remove it and keep it as 1 by 2. So integral of root of x plus 1 plus root of x minus 1 dx would work out to be as follows. So finally it simplifies as 1/3 of x plus 1 whole power 3 by 2 plus x minus 1 whole power 3 by 2 plus c. So the answer is option A. Going to our PowerPoint presentation, so the option is A, which says 1/3 of x plus 1 whole power 3 by 2 plus x minus 1 whole power 3 by 2 plus c. 31st problem, integral of 1 by square root of 2x plus 5 plus square root of 2x plus 1 dx. Now go to our work area, rationalizing, that is multiplying the numerator and denominator with the conjugate. So we get root of 2x plus 5 minus root of 2x plus 1 divided by root of 2x plus 5 plus root of 2x plus 1 into root of 2x plus 5 minus root of 2x plus 1, which will
make the denominator as 2x plus 5 minus 2x plus 1. So with the result you will have from the denominator 4 coming out. We can write it as 1 by 4 integral root of square root of 2x plus 5 minus square root of 2x plus 1 dx. So on simplifying all these things, we get the answer as 1 by 12 2x plus 5 whole power 3 by 2 minus 2x plus 1 whole power 3 by 2 plus k. So the answer is option D. Going to our PowerPoint presentation, it is D. It says 1 by 12 of 2x plus 5 whole power 3 by 2 minus 2x plus 1 whole power 3 by 2 plus C. 32nd problem, integral of 10 power x minus 100 power x dx. Going to our worksheet. Now we know 10 power x, integral of 10 power x and 100 power x as 10 power x by log 10 minus 100 power x by log 100 plus k, and on simplification it works out to be, using all the laws of indices and laws of logarithm, we get this value as 2 into 10 power x minus 2 power minus 10 power 2x by 2 log 10 plus c. So the option answer is option A. Going back to our PowerPoint presentation, it is option A, which says 2 into 10 power x minus 10 power 2x by 2 log 10 plus c. 33rd problem, integral e power x log a to the base e plus a power a log x to the base a dx. Now that can be rewritten. Going back to our work area, we have this original function can be rewritten as e power log a power x to the base e plus a power log x to the power a to the base a dx, which is nothing but e power log e to the log a power x to the base e is nothing but a power x itself. Similarly, a power log x power a to the base a is nothing but x power a itself. So when we integrate, we get a power x by log a plus x power a plus 1 by a plus 1 plus constant c. So the option is B. Going to our PowerPoint presentation, it is B, which says a power x by log a plus x power a plus 1 by a plus 1 plus c. 34th problem, integral 3 power x plus 2 power x by 6 power x dx. Going to our worksheet, integral 3 power x plus 2 power x by 6 power x dx. When you club it, you get it as integral of half power x plus half 1 by 3 power x dx, which is nothing but half power x by log 1 by 2 plus 1 by 3 power x by log 1 by 3 plus k. And using the properties of indices and logarithm, on simplification you would get the answer as minus 2 power minus x by log 2 plus 3 power minus x by log 3 plus by log 3 plus constant k. So answer is option A. Going back to our PowerPoint presentation, it is option A, which says minus of 2 power minus x by log 2 plus 3 power minus x by log 3 plus c. 35th problem, integral of 1 by x log e power 4 to the base x power 4 dx. Going back to our work area, we know that log e power 4 to the base x power 4 is nothing but 4 by 4 log e power log e to the base x. That is the property of logarithms. Then again, which is nothing but log e to the base x, and which can be written as 1 by log x to the base e. So the integral becomes 1 by x log x dx. Substituting log x equal to t, we get 1 by x dx equal to dt. So integral dt by t is equal to log t plus c, or log of log x plus c. So the answer is option B. Going to our PowerPoint presentation, it is B option, which says log of log x plus c. 36th problem, it says a power log x to some base minus x power log a to the same base divided by x power log a plus a power log x dx. We know that, going back to our work area, but we know that a power log x equal to x power log a. Therefore, the above integral becomes integral of 0 by some quantity dx, which is integral of 0 dx, which is 0. So the answer is option D. Go to our PowerPoint presentation. The option is D, which says it is 0. So 0 is the answer. 37th problem, integral e power 4 log x minus e power 2 log x divided by e power 2 log x plus e power log x dx. Going back to our work area, now e power 4 log x is written as e power x power 4 to the base e. Then the other terms will follow as e power log x squared to the base e divided by e power log x squared to the base e plus e power log x to the base e dx. Now integrating x power 4 minus x squared, because we know that e power log of any item to the base e is that item itself, that is x power 4, and respectively x squared and x squared plus x into dx. Now x power 4 plus minus x squared can be factorized as x squared plus x to x squared minus x by x squared plus x in dx. So on simplifying, you get integral of x squared minus x, because x squared plus x divided by x squared plus x will get cancelled. So you are left with the integral of x squared minus x dx, which is nothing but x cubed by 3 minus x squared by 2 plus c. So the answer is option A. So going by the PowerPoint presentation, the option is A, which is x cubed by 3 minus x squared by 2 plus c. 38th problem, integral 1 plus x by x into x plus log x whole power 10 dx. Going back to our work area, we replace x plus log x equal to t and then differentiate. We get 1 plus 1 by x dx equal to dt, that is x plus 1 plus x by x dx will be equal to dt. Now the original integral will become 1 plus x by x dx, replace it as dt, and x plus log x as t. So you'll get integral t power 10 dt, which is t power 11 by 11 plus c. So reverting to the original expression, we have, instead of t, you replace it with the x plus log x. We'll have 1 by 11 into x plus log x whole power 11 plus c. Answer is option A. Going to our PowerPoint presentation, it is option A. It says x plus log x whole power 11 divided by 11 plus c. 39th problem, integral f dash of x into f of x dx. Going to our work area, substituting f of x equal to t, f dash of x dx is equal to dt by differentiating. So it becomes, the original integral becomes integral t dt equal, which is equal to t squared by 2, which is equal to 1 by 2, replacing the expression for t as f of x whole squared plus c, which is option B. Going back to our PowerPoint presentation, it is option B, which is f of x whole squared by 2 plus c. 40th question, integral x into e power minus 1 minus x dx. Going to our worksheet, we take u x as u and dv as e power minus 1 minus x dx. So you have v equal to e power minus 1 minus x by minus 1, and du will be dx. Using integral u dv equal to uv minus integral v du, we have integral x e power minus 1 of 1 plus x dx will be equal to substituting the relevant u, v, integral v du, etc. And on simplification we get it as minus e power minus 1 plus x, the entire thing now multiplied with x plus 1 plus c. So the answer is option B. Going back to our PowerPoint presentation, it is option B, which says minus e power minus 1 minus x, the entire thing multiplied by x plus 1 plus c, as shown in the presentation. 41st problem, integral x cube into e power minus 2x dx. Going back to the work area, if you take u as x cube and e power minus 2x as dx, e power minus 2x dx equal to dv, I can generalize this formula, integral of u dv as uv minus v1 u dash plus v2 u2 dash minus v3 u3 dash, where v1 v2 v3 represent number of times we integrate. v1 means once we integrate, v2 means twice, v3 means we integrate 3 times, that dv. Now u dash, u double dash and u triple dash represent number of times we differentiate, that is u1 dash will be once we differentiate, u2 dash will be twice we differentiate, u3 dash thrice we differentiate. Therefore we get x cube e power minus 2x by minus 2 minus 3x squared e power minus 2x by minus 2 into minus 2 will become plus 4, then plus 6x e power minus 2x by 4 into minus 2 will become minus 8, then minus, because that as shown in the general formula, so 6 into e power minus 2x by minus 8 into minus 2, which is 16. So it is minus e power 2x whole bracket x cube by 2 plus 3x squared by 4 plus 6x by 8 plus 6 by 16 and a constant. So the answer is option A. Going back to our PowerPoint presentation, it is option A, which is minus e power minus 2x within bracket x cube by 2 plus 3x squared by 4 plus 6x by 8 plus 6 by 16. 42nd problem, integral e power ax x squared dx. Going to a worksheet, you take u equal to x squared and dv equal to e power ax dx. Now use the general one, now which is uv minus u prime v1 plus u double prime v2. Now that will be equal to x squared, u is x squared, v is nothing but integral of dv, so which is e power ax by a, because dv equal to e power ax dx, so v will be e power ax. Now the next term would be u prime v1, which will be 2x by a squared e power ax plus 2 by a cube into e power ax plus k, so which can be written as e power ax into within the bracket x squared by a minus 2x by a squared plus 2 by a cube plus x. So the answer is option A. So going to our PowerPoint presentation, the answer is A, which says e power ax into x squared by a minus 2x by a squared plus 2 by a cube plus c. Now 43rd question, integral minus 1 to 1 mod x dx we need to compute. Going to our worksheet, we know that mod x is equal to x for x greater than or equal to 0 and mod x equal to minus x for x less than or equal to 0. So we can split the integral as from minus 1 to 0 mod x will be minus x dx, and from 0 to 1, that is plus 0 to 1, integral of mod x will be x plus x dx. So when we integrate, we get this way. So the find on simplification, we get it as 1. So the answer is option A. Going back to our PowerPoint presentation, the option given is A, which is equal to 1. 44th problem, integral 0 to a f of x by f of x plus f of a minus x dx. Go to the work area. Now we take, let I equal to integral 0 to a f of x by f of x plus f of a minus x dx as equation 1. This is also equal to 0 to a integral of f of a minus x by f of a minus x plus f of x dx, that is replace x by a minus x and call this as second equation. Since both are identical, when we add equation 1 and 2, 1 plus 2 will be equal to 2i. So on simplification we get it as equal to integral 0 to a 1 dx. On integrating we get it as a. So 2i is equal to a means I is equal to a by 2. So the answer is option A. Going back to our PowerPoint presentation, the option is A, which is a by 2. 45th question, the equation of the curve passing through 2, 3 and having slope 2x minus 5 at x, y is, I'm going to our worksheet. Slope of a curve is given to be 2x minus 5, which is nothing but dy by dx. Therefore y will be equal to integral of 2x minus 5 dx, which is x squared minus 5x plus c. Now is the equation of the curve whose slope is 2x minus 5. It passes through, the curve passes through 2, 3. Therefore putting x equal to 2 and y equal to 3 in the curve equation, we get 3 equal to 2 squared minus 5 into 2 plus c, and solving for c, which we get it as 9. Therefore the equation of the curve is y equal to x squared minus 5x plus 9, which is nothing but option A. Going back to our PowerPoint presentation, it is option A, which is y equal to x squared minus 5x plus 9. 46th problem, integral x minus 1 by x squared into e power x dx. Going to our work area, integral x minus 1 by x squared e power x dx can be written as integral of 1 by x minus 1 by x squared, the whole thing multiplied by e power x dx. If we take f of x equal to 1 by x and f dash of x equal to 1, minus will be minus 1 by x squared. Now integral of e power x f of x plus f dash of x into dx will be equal to e power x f of x plus c in general. Now in our integral we will have of the same format, so the answer would be e power x by 1 by x plus c, that is e power x by x plus c. Answer is option C. Going to our PowerPoint presentation, option is C, which is e power x by x plus c. Going to the 47th problem, integral of 2 minus x by 1 minus x whole squared, entire thing multiplied by e power x dx. Go back to our work area. I write 2 minus x as 1 plus 1 minus x, and then divide by that same 1 minus x whole squared e power x dx. So when you split it, it becomes 1 by 1 minus x whole squared plus 1 by 1 minus x, okay, into e power x. Now if f of x is equal to 1 by 1 minus x, f dash of x is equal to will be equal to 1 by 1 minus x whole squared. So it is of the general form integral e power x f of x plus f dash of x dx, which is equal to e power x f of x plus c. Here we will have as e power x by 1 into 1 minus e power x into 1 by 1 minus x plus c. This is equal to e power x by 1 minus x plus c. So the answer is option C. That is C option, e power x by 1 minus x. 48 question, integral 0 to 5 x power 3 by 2 divided by x power 3 by 2 plus 5 minus x whole power 3 by 2 dx. Going to our work area. If you call this as equation 1 equal to some I, this will be also same as integral 0 to 5 minus x power 3 by 2 divided by 5 minus x power 3 by 2 plus x power 3 by 2 dx, which is also equal to the same I. Call it as equation 2. When we add equation 1 and 2, we get 2i on one side. On the other side, it the numerator and the denominator will be the same, so it will become 1. So it will be 1 dx, or when you integrate it from 0 to 5, 1 dx will be nothing but 5. So I will be equal to 5 by 2, or the answer is option B. Going back to our PowerPoint presentation, it is option B, which is 5 by 16 root 2 upon by 15. 50th problem, integral 0 to 2 x root of 2 minus x dx. Going to work area. That is also equal to 0 to 2 of 2 minus x or into root x dx. So when we integrate, when you again expand it, it will become integral 0 to 2 root x minus x root x dx. Now when we integrate this, we will get as 2 into x power 3 by 2 by 3 by 2 minus x power 5 by 2 by 5 by 2. From the limits are from 0 to 2, and on substituting and simplifying, we get 16 by 15 root 2. So the answer is option A. Going back to our PowerPoint presentation, it is option A, which is 16 by 15 root 2 is the answer. Thanks for your patient hearing to solutions on integration. For any other doubts or queries, please mail to the email address graymatteracademics.com. Thank you. See you next time. Bye.